Thank you for the attention. So today I would like to talk about the updating datasets, and I would like to cover the case when you have a dataset, you have a model, you have a production, and you started to get in some errors, some feedback, something, and it takes like maybe 1 month or two to like collect everything, and then you need to improve. So you have to iterate. I'm working as lead data engineer at Bruno Development, and we built like for the last 3 years, like 6 projects, and now they are processing maybe just a few millions photos per month. So I would like to be on the practical side here. Uh, when we have a small team, where usually there is just one owner of the project, and when we have not so big data sets, like if we talk about computer vision, it can be maybe started from 2000 till 100,000. Then we can see that there is a lack of existing solutions. And you have to try to do everything with your scripts, with your dataset formats, and you have to feature like from ground what can you do. I will show you one of the examples of our projects, which will be like contain number recognition, quite simple, but we can like ground practical to understand what we are talking about. So we started from 2,000 images for segmentation OCR, and then it grew to 10,000, and moreover grew a lot the processing logic. So we had to add new types, we had to add new preprocessing, and sooner we had a lot of scripts. So here I put just I don't know, like 8, but actually we had 15, and in some extreme cases even 30. And you like just don't know what you have to run again when it was like 2 months ago, and you start to think like, okay, we export that data. So it was old model, it was created in class 1, but now we map it to class 3. So we have to do this pre-process, and we have to do some validation before we train, and what should we do next. And it was so bad that we started to spend like around 7 days on adding data, and the worst thing, we had to make same mistakes. So like we do mistake and we say, yeah, but actually we did it before. So that's what I said. The issue is when you don't have a continuous flow, but actually you have a model, and you have to wait while this model will collect the data. So if, for example, it's car damage processing system, you collect cases when model was not correct, or when the confidence was low, or maybe you collect data which was missed and it was collected by your users. And it takes time, so you cannot just collect it in one day and improve your model, so you have to wait. So what solutions we have now? We have a bigger tools. So it's like mentioned Airflow, Daxter, but they are obviously too big for just like one data set. And if you are a human in the loop, because if you have annotators and you check the data, then probably such tools may be not a right fit, because you will spend more time on setup all that orchestration databases and so on, while you can do that just with the scripts. There are also platforms like RoboFlow and others which claim to do like all in one. So you can like upload data, annotate it, train, and even deploy, but they usually lack flexibility. So you have to do a lot of things by hands, and you still likely have a export import cycle when you have to import data and export it when you need to do something. So what can we do? Our team actually decided that we have not just make scripts, like give them correct names or something. We decided that we can create stages where each stage is a script with a number, and we can actually exactly know what we do. Like we start from first one, then we go to the second one. When we in the process of work, we know, I was on the 5, then I go to the 6. And the main idea is that they are entry points for you to add more logic. So if you need more preprocessing, you go to step 2, it's export, and you extend it, and you give it a structure. And this way we were able to cut the processing time from 7 days just to 2 days, and which is more important, it become to be a more pleasant process, and we get way less errors. So I would like to cover some of these processes, the most interesting ones, and give some practical insights, which I believe can be interesting. So first is analysis. So here we get data from production and we see, do we have any like specific patterns? For example, if we are receiving new type of containers or something like that, and should we actually annotate all data, or can we take just 200 from 2000 and annotate them? Export is when we convert the data into our dataset format, and data from production often comes pre-annotated, so it can be an important step. Then one is a big one, annotation, the most obvious one for, I guess, everybody. Here we have known tools like CWAT, RoboFlow, and they're great and flexible. But it was funny, but actually it's really simple to create our own OpenCV annotator, and in some cases it can be really great. So you can just make it adjusted for yourself. It works directly on your local files, so you don't have that import-export cycle. Like, for example, you go to RoboFlow, you upload your 10,000 images dataset, then you work on it, and then you see just one error in one image, and you have to do all over again. You have to download zip and so on, or use API. So, for example, for us, the most important thing was ability to zoom just over annotation. So we press space, it zooms, we can adjust the annotation, and when done, we press space again, and we switch to another annotation. So the main idea here is that this tool can be built like in a days, and in this time with AI, you can build it in literally in hours. You can add any hotkeys, everything, and we save probably hundreds of hours on annotation just because we built our own tool. So let's say we annotated data. So like data is probably correct. What should we do next? We have our data set, and for example, it has 20,000 images, and we try to add maybe 1,000. So should we copy that data just inside our main data set? The question is not exactly, because once we copy images into the main dataset, they are mixed, and we don't know yet if these images are actually improving the model. And we cannot know that. We know only when we train and when we evaluate. Our team had such a bad case when we processed 3,000 images, merged them into the main database. Then there was like some mistake in the new data. We tried to restore from backup, and we restored, but instantly removed all 3,000 and lost 3 days of work. So it was quite negative experience. The idea, maybe the key idea, is that we can use a staging folder where we copy files inside another folder and put it to the main dataset. And we can iterate these files even before our model is, even after model is trained. So we can like check if all is good, and only if all is good, then we go next. So let's say we create a staging folder. Now is an obvious step, which is train prepare. It can be useful whatever dataset you use. So we use internal dataset format, but you can use like RevData or Cocoa, but still it can be good because, for example, you would like to split dataset into multiple folders. So in this case, when you want to train, you still need to assemble a dataset into the specific format. So it can be YOLO or RevData or several formats for OCR. And we can treat dataset like our own dataset like high-level language, and the final dataset, like we can say assembly or something like that, which is used just for the training. It also worth to mention about train-val split. So why I mention it? Because for the small datasets, it has much bigger impact. If we have a random train-val split and we add new data, then probably we'll not know is model improved or degraded because of the better new data, or is it just because lucky or unlucky train-val split? And in our experience, we had a lot of cases, maybe 5, when model degraded, and then we tried to investigate, and we found out that train-val split was just, like to say, unlucky, but because it was just 2,000 images. Yeah, and the idea is you can just fix the split without making folders, files, and adds, and increasing your complexity of your structure. Like you don't need to create train, val, and split every time you add new data. And you create just one file, and you put there what goes to train, what goes to split. And what is more important, when you add new data, you don't regenerate the whole split. You only update it with the new files. So this way, we always know that, yeah, model improved or degraded only because of the new data that we add. So next, we train model locally on GPU, something like that. We use cloud providers because it's easier. We copy a zip with internal database and unpack it, transform it, and then we run training. And when training is finished, we receive just a link in our Telegram account with a link to the model. So this way we save some money and time. We give some name to the model, which we can remember in 3 months or half a year if we don't use model registries. Because maybe we had a not so good team, but our names for the models were really bad. So it was like V5 or Sierra. And in 6 months, we didn't know what was it. So when we have a new model, we have to answer the question, is this model actually better? So is it better on new data? Is it better on the data we add? We check metrics, we check visually. So yeah, visually it's better, metrics are better, yeah, great, we go next. Here's funny thing, we can take the trained model and we can run it on the addition that we did. So the model was trained on that data and we run model over that data. It's not obvious. But if you have a big data set like 20,000 images and you have just 2 errors, then model for sure will find these errors and will help you to correct them. So this example, this annotation, which was in the sky, it was just a small example. And it was like a 3 times, I had 3 rounds of corrections and I didn't see it. And then this way, this check helped to find it out. So when we come to the final step, we see, should we actually now make the new data a part of our data set? So are they good enough? So if they do, then we merge with dataset. If they not, then we go back and we check what is wrong. So for example, we have a wrong class. For example, we have wrong notation, or we can have too little data. So we have to collect more samples, more data, and retrain the model. So let's say all is good. Then we just go next. We copy files to the main dataset. We do backup, like incremental backup with Restic or DVC push, and that's it. Another thing which quite opinionated, but I decided it makes sense to share, is ability to store annotations in GPG metadata as well as PNGs and TIFFs, if you talk about computer vision. So here, like when we use datasets like YOLO, like Coco, what should we do to move the file? We have to write a script or use some UI tool and we move, but there can be a lot of different errors like orphaned annotations when you moved file and forgot to remove annotation, or even worse, when you have annotation name for the file, but it's a wrong file. these are especially hard to spot. So if you work with not so big data sets, and you would like to simplify dataset structure, I believe it makes sense to put data just inside, and you can just copy, delete, experiment, do whatever you like, and your file, it's always like self-contained. And when you need to train, you just convert dataset format and you train. So it saved us enormous amount of times, and we tested it on a lot of projects, and it was great. Of course, it doesn't work well if you need to version a lot. If your data is like you have a lot of annotation changes and your data is static, yeah, in these cases, it's not what you should use. So what I would like to say, we were able to test it on over 2 years on 6 projects and data sets from 2,000 till 100,000 of images, and to reduce the time of adding new data, and moreover, it became more pleasant process. So if before our team was, oh, we have to add new data again, it's so bad. And now we started to have a pain in the process. We started to have thinking like, oh, great, so our model can be improved in that way. So we started to think not about the process, but about the data. So basically, it's not about the tools. You don't need to use own dataset format or own annotator. Basically, it's just a structure when you have stages and you can follow them sequentially. So if you have data sets which you visit from time to time and you have to update them, then it will take like very small amount of time to set up maybe even first 4 scripts and test it out. So thank you very much for the attention. Any questions?